All right, let's get straight into it. Welcome to this explainer. Today we're tackling an absolute monster of a topic that sits right at the core of the Cambridge IGCSE Physics 0625 syllabus, living with electricity. Now listen, we're going to approach this a bit differently today. Instead of just memorizing textbook pages and hoping for the best on exam day, we're going to master these fundamentals through a highly structured, concept-first approach. By the time we wrap up this strategy session, you're going to have a framework that doesn't just help you remember facts, but actually trains you to think like a physicist and crush any wildcard question the examiners throw your way. Let's get started.
Okay, before we even look at a single mathematical formula, and way before we get into any formal physics jargon, we have to start right here. Why do we even care about electricity? A bulletproof strategy for this topic has to begin with a simple question that grounds the physics in reality. What physical effect, what measurement, or what real-world prediction actually depends on understanding how we live with electricity? Because here's the truth. If we can't answer why a concept is needed in the real world, those formulas you're cramming are just meaningless symbols. Here is our highly structured roadmap for today's explainer. We're hitting the starter challenge, then the core 4-step framework, moving into real-world applications, navigating exam traps, and we'll finish up with a quick recall strategy. Section 1, the starter challenge. Make the idea feel necessary rather than decorative. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, think about this quote for a second. It's an incredible realization for your revision. A decorative idea is just a trivia fact. Sure, it looks nice on a flashcard, but it doesn't actually do anything for your grade. A necessary idea solves a real problem. When we start with a real-world necessity, it completely shifts how your brain stores the information. It stops you from just relying on memorized wording. When an idea feels necessary, the learning becomes deeply practical, which means you are far more equipped to reason your way through unfamiliar, tricky scenarios where rote memorization just completely fails. Section 2, the 4-step framework. If you want to truly command this chapter, you need to guide your thinking through these 4 linked steps. Consider this your physics success blueprint. Step 1, identify the quantity or phenomena. Basically, what are we actually looking at? Step 2, state the relationship involved. How do the variables interact with each other? Step 3, explain the underlying physics. What is the actual mechanism happening behind the scenes? And finally, step 4, connect it to an observation, an experiment, or a real device. This sequence is absolutely vital, guys, because true exam mastery isn't just reciting facts. It requires you to build an unbreakable bridge between deep conceptual understanding and practical application.
Now, here is a core philosophy that completely changes the game. Insist on cause and effect rather than isolated facts. Whether we're dealing with circuits, electrical fields, magnetic forces, particles, or waves, you cannot just list things that happen to be true. You have to show the chain of events. A causes B, which results in C. That is exactly how an examiner expects a top-tier student to think, and it's how we build a rock-solid understanding of these complex systems.
Here is a fantastic pedagogical trick to wrap your head around a difficult concept. Move gradually from everyday language to your strict physics vocabulary. It really helps to avoid starting with the hardest equations, and instead begin with a concrete, everyday example. Once you firmly grasp the physical reality, only then should you bring in the symbolic relationships or formal definitions. And hey, if a topic involves graphs, don't just memorize the shape. You have to figure out what the slope, the area, the direction, or the shape actually means physically. Does the slope represent resistance? Does the area represent energy? You always need to tie the math back to the physical world.
Section 3, real-world applications. Depending on the specific micro-topic you're looking at within electricity, these ideas literally appear everywhere. We're talking engineering, vital safety protocols, modern transport, vast energy systems, global communications, life-saving medical technology, and even astronomy. A true master of physics doesn't just know the textbook definitions. They can always name at least one real situation where the concept actually matters. More importantly, they can clearly explain why the physics helps us predict or improve outcomes in that specific field.
Section 4, navigating exam traps. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's talk about where students lose marks.
There is a stark, undeniable contrast here between a student's gut instinct and actual exam strategy. Let's say we have two students. A weak answer often comes from the flawed instinct of just dropping a correct formula onto the page without analyzing or explaining any of the variables. It's so easy to think, hey, I wrote the math, I'm good, but you're not. You miss the command word requirements entirely. Compare that to the safest, absolutely bulletproof method, providing the definition, stating the relationship, offering the physical explanation, and finally giving the application. That four-step progression we discussed earlier is literally a shield against losing marks.
Let's drill down into these specific super common weaknesses so you can eliminate them from your answers entirely. First up, unexplained formulas. If you write E equals IR, but you don't explain what E, I, and R physically represent in the exact context of the question, the examiner is taking your marks. Second, quoting processes without physical links. You can't just say a process happens, you have to link it to the physical effect that actually causes it. And third, giving examples without physics justification. If you write that a fuse is an example of electrical safety, that's great, but why? How does the physics of the melting wire justify that example? Every single answer you write must be tightly connected to that cause and effect reasoning we talked about earlier.
Section 5. Quick recall strategy.
So, the crucial takeaway here is this. When you are revising a microtopic in electricity, you need to use these four specific recall prompts. Number 1, what is the core idea? Number 2, what changes physically in the system? Number 3, what exact quantity, equation, or graph shows this concept? And number 4, where is it used in real life? If you can answer these four prompts aloud without looking at your notes, then, and literally only then, is the topic secure enough for you to tackle the hard short answer and structured questions.
And that brings us to the end of our deep dive. I want to leave you with a final challenge. Can you answer those 4 recall prompts aloud right now for whatever physics topic you're studying next? Don't just nod along, actually test yourself. Apply this framework, and it will completely change how you prepare. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at ACExams_IGCS to excel in your Cambridge examinations. Subscribe right now to ACExams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.